Today's lesson, we're going to look at more specifically rounding significant figures in calculations. And I also want to say that we can both use the term significant figures and significant digits, and they're used interchangeably. So our goals for today are, can we round the answers to the proper sig figs in addition and subtraction? And it's slightly different rules for multiplication and division. Let's look at some examples. So an answer can never be more precise than your least precise measurement. Sometimes when we put things into the calculator, it spits out a whole chain of numbers, and we have to be careful to only be as significant as our measuring device, just like we learned in class. So for adding and subtracting significant figures, you round your answer to the least number of decimal places. Let's take a look at that. We have 3.75 milliliters and 4.1 milliliters. Calculator answer is 7.85. However, my 4.1 was only measured to the tenths place, which means my final answer has to be rounded. If I look at my significant figures there, and I'm going to round that to 7.9. So I do my complete math, but I recognize that I have one place after the decimal for both of them, so my answer can only have one place after the decimal. Subtraction works exactly the same. Let's take a look at some of these examples. 2.0 plus 5.61, and in both of those my decimal is present, so I'm going to start on that Pacific side. So I have two significant figures, so I have one number after the decimal and I have two numbers after the decimal, which means my answer for that first one can only have one number after the decimal, which is what it's showing me there. Least precise place value is the tenths place, and so I'm going to end up with an answer of 7.6. When I calculate our answer 5.67 plus 102.111, again, hundredths place. The least precise place value is the hundredths place, so I need to round to the hundredths place. My answer in that case is going to be 107.78. And for my last one, 23, which has no numbers after the decimal, and 11.10, I get 34.10. But since I have no numbers after the decimal for 23, my answer shows me my least precise place is the ones place, and that means that my answer needs to be round to 34. Okay? Subtraction would work exactly the same way. All right. Now, looking at multiplying and dividing, they follow the same set of rules. We're going to round our answers to the least number of significant figures. For example, 13.91, those are all numbers, so there's 4 significant figures there. 23.3 has 3 significant figures. I'm no longer concerned with the decimal places, I'm concerned with the number of significant figures. My lowest number, so 4 sig figs, 3 sig figs, like I just said. My lowest is 3 sig figs, which means my answer has to be rounded to 3 sig figs. In that case, I'm going to round it to 324, even though my calculator spit out other numbers. Let's take a look at some of these examples again. So some of the same numbers, but now we're going to multiply them and divide them. 2.0 times 35.1 gives me 70.2. But I'm going to round that to 70. 2 significant figures for 2, 3 significant figures for 35.1, and then tricky. I have to write 70 and then just a decimal. And this is a tricky one. If I don't write a decimal is absent, I only have one significant figure. If I write 70.0, now my decimal is present, but because I've added that 0, it's 3 significant figures. It's one of the trickiest examples that you could possibly have. Let's look at the next one. Let me explain it before I put the answer up there. 5.11, 3 significant figures. 98.654, 5 significant figures. So my answer needs to have the 3 significant figures that I'm showing you in red. 72.1, that's 3 significant figures, divided by 3.123, 4 significant figures, which means my answer needs to be rounded to 3 significant figures. I'm going to have 23 point, and then because that's an 8, I round up, and I end up with 23.1. And then another division problem, 56 grams, 2 significant figures, divided by 12.45, which is 4 significant figures. My answer is only going to have 2 significant figures because I have 2 in that 56. So, rounding answers to proper significant figures in multiplication and division calculations, that's what we're doing in terms of using the least number of significant figures in the calculation. And then rounding your answers for addition and subtraction, there we're looking at the number of decimal places. Let's take a look at scientific notation. I know this is something you're familiar with, but I really want to show you the calculator sequence that we have going on here. So how to convert numbers into scientific notation and how to do some calculations using scientific notation. A way to represent large and small numbers in scientific notation, for example, the mass of a hydrogen atom is very, very small, and that's a lot of zeros to write out. So we can write that as 1.67 times 10 to the negative 24th grams. We move that over. 2 grams of H2 contains all of those molecules. We can write that as 6.02 times 10 to the 23rd molecules. Much easier numbers to deal with. So it's written as M times 10 to the n. M is a number between 1 and 10, and n is the number of decimal spaces moved to make M. So find the decimal point. If it's not written, it's at the end of the number. So 2457 has a decimal at the end of the number. Move the decimal point to make the number M between 1 and 10. So there's my pretend decimal. I put it in, and then I'm going to move it over once. I'm going to move it over twice. I'm going to move it over 3 times, and from there, I'm going to put that decimal there. Now I have 2.457, and if the original number was above 1, which 2,457 was, the exponent is positive. If it was smaller, then it's negative. So our bigger numbers, we're going to have that positive. So 2.457, and I'm going to add in times 10 to the third because my original number was 2,000 something. Now, to look at expanded notation, okay, so now we're going to put this decimal here. It's imaginary. We don't see it. We're going to move it 1. We're going to move it 2. We're going to move it 3. We're going to move it 4. I'm going to write this 4 places. So 4.5450 times 10 to the 4th. Take a look at those significant figures. That's important because if my original number, I have to look and see how many significant figures my original number had and then see how many my answer should have. So in this case, I probably should have written 4.545. We'll talk about that specifically in class in terms of significant figures and scientific notation. Here, I'm going to move this 3 places. And by moving it 3 places, the number is smaller than 1. That was 0.000453. And I end up with 4.53 times 10 to the negative third. And my exponent is negative. So, can you convert numbers into scientific notation? Let's take a look. Negative exponent, we're going to move the decimal to the left. 0.045, we moved it 2 places because it was a negative 2. If we have a positive exponent, we're going to move it to the right, and we're going to move it 3 places. So 1, 2, 3 gives me 2,600 milliliters. And so for checking, can we convert numbers into standard notation? Now, please take a look at this calculator. This is a good basic calculator, and I will show you in class if you have different calculators how to use them to make sure you type, but this is a pretty common one, the one that I have in my classroom and the ones that a lot of you have. When you go to type this into the calculator, 5.44 times 10 to the 7th, I want you to type 5.44, and I don't want you to use, if you have a times 10 to key on your calculator, it's going to tend to make mistakes. I want you to type second, and you see it circled on that picture, and then when you hit second, the thing above that is a little EE. So I want you to type second and then EE, and then your exponent is 7. That's how I need you to use your calculator all year. We'll practice with that in class to make sure we're all using it the same. And then you're going to hit the divided by key. And I strongly encourage you, if you're following along with this, to get out your calculator and do this along with me to make sure that you see what to do. You're going to type 8.10, and then you're going to hit that second and EE key, and you're going to hit 4. And that's going to give you an answer. You're going to hit enter, and it'll be in long form, 671, 60493, and we can figure out significant figures and things from that. But I just wanted you to see the typing of exponents into the calculator follows that second EE key. That's going to be our best friend this year in terms of all of the things we do with exponents. We do round that to proper significant figures because I have 3 significant figures in 5.44 and I have 3 in 8.10. So my final answer is 672, which is the proper significant figures. Okay, and checking your understanding, can you use the mathematical operations while using scientific notation? Can you convert numbers into scientific notation, and can you calculate mathematical operations using scientific notation? So those were our goals for today's lesson. We will practice with our calculators in class, and if you have questions about any of this, please make a note so that we can go over it in class when we're together.